start off first of all, just a little warm-up problem. So I want you to read this question and answer it. It says, which costs more per pound according to the graph, peas or cabbage? And don't just give me a one-word answer, but I also want you to explain how you know which one it is. So use just a few seconds to do that, and then we're going to go over it. You can just add that to your previous bell work. Very good. Very good. Now I see several different answers, but that's okay, because I want you to be able to explain why you said what you said. How many think it's the cabbage that costs more per pound? It's okay, don't change your answers, it's okay. And why did you say that, Parker? Why did you say that you thought the cabbage was more per pound?
Because it's sloped more towards the cabbage than the peas on pounds.
So it sloped more towards the pounds, is why you said that? Okay. Someone that said that the peas cost more. Tran, why did you say the peas cost more?
I said the peas cost more because no matter where you are on the graph, the slope is higher on the cost range.
Okay, what do you mean by the slope? The slope is higher.
How diagonal the line is, because if you go to the very tip, the peas slope is higher than the cabbages.
Okay. It is the peas. It is the peas. Because here, what axis is this? The x-axis. So the x-axis is talking about pounds. As pound is increasing, what's happening to the cost? It's also increasing on both of these, which means if the pounds and the cost for the cabbage is here at that same poundage, the cost for the peas is what?
Higher.
It's going to be higher. Okay. Everybody understand that? Okay. Yesterday we talked about graphing linear equations. Who can remember what were some of the ways that we can use graphing linear equations? What did we do? We just started graphing. What did we do to graph linear equations? Ryan, what did we do to graph linear equations?
We use some tables.
Okay, we used tables, function tables. What else could we use on that?
We used ordered pairs.
Ordered pairs. What does the ordered pairs tell us, Bailey?
It tells us like the number of the x, like what number it's going to be on the x and y axis.
The x and the y axis, very good. So we used the ordered pairs from the tables to graph that. What else did we talk about?
Fractions.
Fractions, okay. Did we use fractions to graph though? What did we talk about with the fractions?
They were slope. Like slope is a fraction.
Slope can be used as a fraction. Why can it be used as a fraction?
Because slope is a number over a number, and so it's rise over run.
Okay, so it's a ratio, which is a fraction. Okay, very good. So today we're going to elaborate on that a little bit more, and we're actually going to use a task to investigate rate of change in slope. So we're going to take it just a little bit further, and we're actually going to use triangles, similar triangles. What do I mean by similar? What do I mean by similar? Tria?
They're proportional.
They're proportional. What does proportional mean?
That if you enlarged it, it would be the same as the other triangle. If you shrank it, it'd be the same as the other side.
Okay, very good explanation. So we're going to see why similar triangles is going to help us explain why slope is the same between any two distinct points on a non-vertical line. Show me with your hands, what does vertical look like? What does vertical look like? Show me with your arms. Is it like this or is it like this? What's vertical? So it's straight up and down. So anything that's non-vertical, which means it's not going to be straight up and down, we can see how the distance between any 2 points on that non-vertical line is going to be the same. Then from that, we're going to derive the equation y equals mx for a line that goes through the origin. Who can tell me where the origin is? Where's the origin? Taylor, where's the origin?
Right where the x and y axis meet, right in the middle.
So that ordered pair is going to be what?
0, 0.
0, 0. Very good. So at the origin, it's just going to be y equals mx. And for a line that's not through the origin, it's going to be y equals mx plus b. How many like music? How many like music? I like music. What are some ways or places that we use music or see music or hear music? What are some different places that we would have music?
In your car?
In your car, just riding around, listening in your car. What's another place?
In an elevator.
In an elevator, when you're sitting in the elevator, you hear do-do-do-do-do-do-do. Taylor, what's another place?
At home.
Just at home, okay. What were you going to say?
At a dance?
At a dance. Sometimes we have school dances.
When you go shopping, a lot of stores play music.
Very good. At stores, a lot of times they'll have music. Well, we're not going to talk directly about music, but how many of you all buy CDs sometimes? Y'all buy CDs? Okay. So we're going to look at how, on a graph, how we can relate the price of CDs, and they're not always the same price, but we're going to just give like an average price of a CD versus how many CDs you may purchase or you may have. So we're going to use that to do a little investigation. And in our investigation today, we're going to have several different segments. First, when I pass out the task that we're going to work on, I'm going to give you a few minutes of private think time. That just means that for the first few minutes, for 5 minutes, I just want you to kind of look at the sheet, answer the first few questions, and just kind of see what you can think about on your own. Then after we have that private think time, we're going to then get in our small groups that you're all already in, and y'all are going to discuss what you've already found on your own, and then you're going to further finish that worksheet. Then, and I don't have this on here, but from that small group work, we're going to add 10 more minutes, and that's when I'm going to give you a chance to put your findings on the larger posters that you're going to share with the whole group class at the end that we'll discuss in the last 10 minutes. Okay? Are there any questions right now as far as what we're going to be doing today? Okay, I'm first going to go ahead and pass these out to the groups. And I just want you to go ahead and put your name and date on this. Here you go. Just make sure everybody in your group gets one. All right, on this task, it's called Music is a Must. It says the data shown in the graph below reflects average cost of a music CD. So you're going to take this information that's in the graph, just whatever you gather from it, and you're going to answer the first few questions. All I want you to do right now in your private think time, I want you to actually just work on or answer letters A through D. So right now, in this first few minutes, you're just doing letters A through D. But when you finish with A through D, go ahead and just to yourselves read the other few questions just so that you already have an idea of what we're going to work on as a group. So, but for the first 5 minutes, just doing A through D right now.